measuring, um, the measuring tape and the dye are in one big plastic Ziploc. So like when you're looking for it, you're gonna want to pull out the plastic Ziploc out, and in there you're going to find the dye and the measuring tape. So once you guys have that, say got it. If you don't have the dye right away, yes, Christian, what's up?
I accidentally forgot the measuring tape. I thought it only meant regular tape. It didn't say the word measuring tape.
That's okay. You don't need the measuring tape. Do you have your ruler?
Yes.
Okay, then that's fine. You don't. It's okay if you just have the measuring tape.
Cool.
Ugh. I meant to say it's fine if you just have the ruler. Okay. All right, so once you guys are done with that, say ready in the chat so I know that we can move on. All right, great. Christian is ready. This is 2.9 Kaya, yes. Great. Dunny, yes. Okay. All right, so it seems like most of us are ready to go. So we are going to move into the labs. So when we're taking a look at this lab sheet, right, they tell you there's also a link that's going to take you to the lab report. So remember, you are not going to be turning in the direct lab report for this, but you are going to be participating in a class discussion. The key word that we're going to be talking about is something called directional selection. So this is a type of natural selection. We're getting into evolution. So we're learning about how species have changed and evolved over many generations. So, you know, you may have heard of the term evolution before, but maybe you don't know exactly what that means, right? Especially when it's referred to in like Pokemon Go, and you evolve your Pokemon, right? But what does that mean exactly? In the game, they say evolve, meaning it changes into the next best player, but in one single individual's life, and that is very different. Same idea, but different in practice when it comes to evolution in nature and what we see over the last thousands, millions, and billions of years on Earth. So when we talk about evolution, one thing that I really want to stress out is that it is really about the change in a population over many generations. So there are two key things in that statement. Population. Evolution, natural selection is one way of evolution, and that is not going to happen in one individual's lifetimes, okay? But instead, it happens over many generations. We're going to understand how that works. Again, natural selection is just one way that we talk about how these, we talk about alleles, right? We talk about variations in genes and traits. We've talked about this last quarter. We talked about this in the first unit of this quarter, where we talk about how different genes are going to be expressed through proteins and structures. And sometimes those structures benefit us, right? Sometimes it's better for an organism to have a longer neck, if you're a giraffe, so you can reach higher trees if there are no more trees that are lower to the ground, right? And so remember that you're going to be learning about this in the next units this week. We're going to be talking about that. More specifically, in this lesson, we're going to see how the environment impacts the changes or natural selection, the traits that are going to live on and go into the next generation. So when we take a look at our paper, when we take a look at the lab, we're going to have it structured in the materials. And I found this by going to the introduction section of the lab and downloading the student document, the PDF, okay? So that's where I found this paper. The first part, you are to take notes. That's why it says online. You are supposed to be taking notes on the Learn section of the lab of this 2.9 lesson. Now, activity 2 is when we are doing this lab. So when we have this, right, we are going to we need to set up our lab. So this is where the paper and the scissors are going to go on and follow the directions. I agree, Christian. I love my birds, so I feel bad too. So, okay, first thing that you're going to do for parent 1, which has short legs, you are going to cut out a strip of paper that has that is 4 centimeters by 10 centimeters. So with your paper, now I already have one that's been cut, okay? But with your paper, your new one, you should only need one. You might want to have more for backup. But you're going to take your ruler, okay? And you're going to measure 4 centimeters by 10 centimeters. So what that means, and I have found it easiest to use it on the side of the paper. So as you can see, I've already cut like over here on the paper and over here. So what I would recommend is taking the edge of your paper and using your ruler, making sure that you're using the centimeters or the metric side, right? So when you take a look, this is inches on the bottom, centimeters are going to be at the top. So using your ruler with the metric side, I want you to take the edge of your paper. Let me get a new one for you so I can show you what I'm doing. Take the edge of your paper, and I want you to measure. We're doing 10 centimeters first. So taking your ruler, making sure you're lining it up with the edge. So not the edge of the ruler, but where the first line is. And you're going to measure 10 centimeters. Okay, so 10 centimeters down the page is okay. So when you take a look at that, and then you're going to make a line for where you get to 10 centimeters. Okay, so again, if I'm holding it up closely, okay, so 10 centimeters. Let's see here. I've got my ruler at the edge of where the 0 starts, and then I'm measuring 10 centimeters, and then I'm drawing a line. 10 centimeters is right here. Can you see that? And then I'm going to draw a line. Okay, so go ahead and do that. Okay. But go ahead and do that. Tell me, it does not have to be, it should not be a diagonal. It should be, I don't know what you mean, Christian. It should not be a diagonal. It should be straight across. So like you should be measuring it and then like drawing a line. You're just drawing a line right now. Once you've drawn your line, then you're going to take your ruler again and you are going to measure 4 centimeters within the paper starting at that line, right? So for example, just trying to be aware of time because I don't want us to run out. Oh no, it's only been 15 minutes. I have this until 10:30. Great. Okay, so I've got my, I'm going to do this with you guys. Okay, so I've got my line, right? Can you guys see that? There's my 10 centimeters. Now, with my ruler, I want to measure from that line. I don't know where it is. This is really hard when you do it backwards. Okay, so there's my line. Now from there, I want to measure 4 centimeters, and I'm going to draw a line 4 centimeters long. Like that. Okay. Once you do that, then you're going to draw a line from there to the other edge. And right there, you have your first strip of paper. So then you're going to go ahead and cut that out and leave it to the side. Then you're going to do the next paper and you are going to measure it for 4 centimeters, but by this time, 20 centimeters. Okay, let me know if you have any questions and I will just wait patiently until that is
I'm a little bit confused. I'm sorry.
Sure, what's up?
Where am I supposed to put the 4 centimeter line? I'm not necessarily home, so the environment I'm having to do this at is very difficult.
Sure. So if you take a look, so remember I drew my 10 centimeter line right here.
Yeah.
I kind of marked it. And then I measured from this edge of the paper in to the paper, I measured it 4 centimeters.
Well, that was my first mistake because I didn't put a marker. I just drew a whole line 10 centimeters long.
Yeah. Well, that's okay too. If you drew a line 10 centimeters long, and then you can just draw 4 centimeters from there.
Nah, I'm just going to start over.
Okay. That's, whatever works best.
So 10 by 4 by 20.
Right now, we're just doing 10 by 4.
Okay.
And then once you're done with the 10 by 4, then you're going to make a new one. You can still use the same part of the paper. I mean, you work on the bottom part, right? The opposite of wherever you're cut. You're going to do the same thing for 4 by 20. There's 4 house finches at one time on one feeder. Oh my God, this is making me so happy. And there's goldfinches, you guys. Just type ready in the chat when you've got those 2 strips cut out.
Wait, so now you just do 4 centimeters across, right?
Correct.
Okay.
Again. All right, let me get my other. I have this all set up like a cooking show. Never mind, I lost my strips of paper.
Can I
Let's go ahead and
camera so I can show you if this is right?
Sure. So you are going to want to make that a little thicker. So remember, I know what you did. So we have our 10 centimeter line. You want to measure 4 centimeters using that line to make one thing like this. Okay. Okay, and then Logan, the 6th step is talking about drawing a line in your paper like that. Now, I drew mine and it was permanent markers, so that's why it's bled through, but you're going to draw a line in the inside of your loop on both of them. So once you cut them out, then you're going to make a little loop, okay? So like it says, you're going to make a loop of the strip, but you're only overlapping the ends by 1 centimeter. So you want to make sure that you're not overlapping them much more than that, because then it may just be a little off. It doesn't have to be perfect 1 centimeter, but just try your best. Okay, so you're going to cut the papers out. You're going to put them in a loop. You're going to have them overlap just by a little bit. Use your tape to tape them together. And then you're going to be ready and then make a marker. And then we'll be ready to start the lab. So let me know when you guys are ready. And Christian, I know that you are still working on the measuring. No big deal. Having a hard time seeing yours. It looks better. That looks good. Yeah. Okay. Alrighty. right, so is anyone else ready to start the lab, or are we still needing a little bit more time? If we need more time, that's fine.
So now you just cut out those 2 lines.
Yes.
Okay. Sorry.
You're
Yeah,
cut out that
I feel
strip of paper,
Okay.
and then you're gonna measure.
Okay. All right.
Great. Squirrel is back trying to get the food. All right. Logan is ready. Tara is ready. Denny is ready. Yes. Great. Yay. So many birdies.
So then with your little small strip of paper, you just fold it into a little circle type thing.
Mm-hmm.
Okay.
Great. Okay, so I'm gonna go ahead and move on. So for those of you who are still creating your loops, that's totally fine. Keep doing what you're doing. Just try to listen as I explain what we're going to do. So part B of this lab, we've already set up our lizard legs, right? So remember that the whole premise of this is that there are lizards that are living in California. Right, so if we take a look at our kind of our background information, we've got this orange-throated whiptail lizard that inhabits areas of California. As California's human population is increasing, the lizard's habitat is shrinking, and so is its food source, a certain type of termite. As urban sprawl continues, which urban sprawl is just when people start to develop areas and that urban living starts to spread out into those natural areas. So as urban sprawl continues, will some kind of natural selection act on this lizard population? So we are going to take a look at generations, right? So that is our scenario. We created one lizard, parent 2 with long legs. We've created parent 1 with short legs. So the one that is only 10 centimeters long are to simulate the distance that these short-legged lizards can go. And parent 2, this longer one, is the representation of how far longer-legged lizards can go. Okay, so if we take a look, the parents reproduce and have 6 offspring. Instead of making more of the same models to represent the F1 generation, we're going to use the parent models to collect data. So we are going to use our die, right? So each die has numbers 1 through 6. So for the first generation, the F1 generation, the size with 1 through 3 dots is going to represent the offspring whose legs are 10 centimeters long. So that's going to be our smaller loop. And then size with 4 to 6 dots are going to represent those with 20 centimeter long legs. So what that means is we are going to roll this die 6 times. If it lands on 1 through 3, we are going to be recording that in the table below. So if you go down all the way to the bottom, you're going to see these data tables. And so we're going to be filling these out. Now, if you are following along on the computer and you didn't print this out, then just grab a piece of paper and you can recreate these data tables and then fill them in as we go through. Okay, so again, we are going to, for the F1 for short legs and F1 for long legs, we are going to roll the die. Anytime that it lands on 1 through 3, that is going to be for short legs. And that means that 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 offspring is going to have short legs. And if it goes through 4 through 6, then that means that they're going to have an offspring with 20 centimeter legs, the longer legs. And you're just going to go ahead and write a tally in those for the number of individuals born. Okay, does that make sense? So we're going to roll the die. If it lands, yes, I can. If it lands in the 1 through 3, then that means that we are going to put a tally mark for short legs. If it lands 4 through 6, we're going to put a tally mark for long legs. And this is just for the F1 generation. So that first line in both of the generations. And we're just going to do that first. Okay, so we're not going to worry about the distance yet. So let's just focus on rolling our die. Now I'm going to roll my die, but I want you guys to be rolling your own die and record the information that you have on your lab. Okay, so we're going to roll them together though. So very first time, get your die in your hand, get it ready to roll it. I landed on a 5. So I'm going to collect my data and I'm going to write a tally mark 1 for long legs, right? Because it lands 4 through 6. That means that that individual offspring is representing having long legs, and 1 through 3 is short legs. So we're going to do this 6 times. That was my first time. So make sure you guys are marking your tally in yours. Okay, now I'm going to go through it again. My guy landed on 6, okay, in the data table, Logan. But if you haven't had a chance to print it off, then I recommend that you just do it on a piece of paper. Number of offspring and number of individuals born in this column in that first line is where you're going to write it. Perfect. Yeah, so that just where it says number of individuals born. Yeah, that's where you're going to mark the tally mark. So my second roll was 6, so I have another offspring that's born with long legs. I'm going to go ahead and do this 4 more times. You guys should do it as well. So make sure that you're writing down what you get. I've got 2 more rolls to do. All right, so I've got my offspring. What about you guys? What did you guys get? How many did you get with short legs in the F1 generation, and how many did you get with long legs in the F1 generation? So go ahead and put what you got in the chat. So for example, I got for short legs, I got 4, and I did 2, Elias. I got the opposite. For short legs, I got 4. For long legs, I got 2. Okay. Wow, weird. We're getting like very similar numbers. Some of us have them switched, which is totally fine, right? This is random. This is how natural selection works. Sometimes it's just a random chance that what you get, what you're born with, right? So no problem. Okay, great. So now we know how many number of individuals are born for each one. So this is where it's going to get a little different for each of us, even though we're going to do the same thing all together. So now what I want you guys to do, right? So it says we are going to roll the die 6 times to represent the 6 offspring. You're going to use the data tables at the bottom of the student guide to record the number for each type of offspring in the F1 generation, which is what we just did. Now you're going to find a clear space on a table or a hard surface floor, and you're going to place a piece of tape at one end to mark the starting point for your experiment. So what you're going to do, perfect, Christian. That's what I got too. You can either take tape, okay, to mark your starting point, or you can use anything else. It doesn't have to be tape. You can use the, you're not going to want to use your ruler or measuring tape because you're going to want to use that to measure the distance. But, you know, if you want to put a pen at the starting point, anything, but you're just going to want to mark your starting point. Okay. Now you are going to use the parent models to test how far the F1 generation individuals can travel. So what you're going to do for that, so for example, I had 4 short-legged offspring. So that means I'm going to use my short-legged representation. I am using a pen to start with my marker, like my starter point. I'm going to leave that right there. And then it says that you are going to roll the model 1 full turn for each individual with short legs that was born into the F1 generation. So for example, if 5 short-legged lizards was born, roll the 10-centimeter model 5 full turns. So what that means, that's why we have this line here. So that's what we're going to start with, right? You're going to, on your surface, you're going to roll it down the table until that black line is back to where we started, right? So let me do that again. So for example, I have 4 short-legged offsprings, which means I'm going to roll this 4 times across my table. So when at 1 turn, so I start with the black line on the bottom on the table, and I'm going to turn this and roll it across the table. And when the black line comes back to the surface, that's considered 1 turn. So you're going to turn this 4 times. Okay. All right, Logan. So go ahead and do that. And then once you turn it, however many times you need to turn it, then you're going to measure that distance from where it started to where the end of that turn was. All right, Logan, what questions do you have for me? What part of the, so that way I can address your question more directly. Okay, so remember, there are 2 tables. One table is for those short legs, one table is for the long legs. We're going to be filling these out at the same time, depending on what you roll. So the number of individuals born in the F1 generation, that was when we rolled this, right? And we said to put a tally mark. So you're going to put a tally mark in this line, or, you know, if you're writing the tally mark on an individual piece of paper, you can type in the number. So for example, I rolled a number 1 through 3 4 times. So the number of individuals born right here, I would write 4. Unfortunately, I don't have a way to edit this, but you know, but that's where I would write 4 down right here. And then I only had 2, I only rolled a 4 through 6 twice. So I would write 2 right here, right? Because I only rolled a 4 through 6 2 times. And then the distance traveled is what we're about to figure out. So like, for example, I had 4 short-legged people. Okay, so does that make sense, Logan? So how many short legs and how many long legs did you get? Okay, so with the short leg table, under the F1 generation, you're going to write 2 right here because that's how many you rolled for short legs. So in this line, do you see my cursor? In that line, that's where you're going to write the number 2. And then in this table, in this line right here, because we're still working with the F1 generation, you're going to write down 4 because that's how many individuals were born. Okay, great. And then we're trying to figure out the distance traveled right now. So that's what we're trying to do. So that's why we said turns, right? So for me, for example, I have, okay, so I start right here. So 1, 2, 3, 4. Okay. So I did 4 turns on my 10 centimeter legged individual. Remember to be using the correct side. We're doing this in centimeters. Okay, so my person went 28 centimeters is how far my person went. And did I do that right? Hold on. 1, 2. Nope, I was wrong. That was only 3. 3, 4. Okay, so mine went to 36. So for every individual born, you do 1 roll. So, okay, yeah. So for every individual that's born, you do 1 roll. Yeah, so like, for example, I had 4 people born with the short legs. So I rolled my short leg 4 times. And I had 2 people born with the long leg. So I'm going to roll my long leg 2 times. And that's how far the distance is going to be that's traveled. So 1. Okay, so my guy traveled 35. So for the for the 2 long legged. Right? So that's what we're kind of doing. All right. Does that make sense to everybody? You got 84 for what, Ava? For the short legged or for the long legged? And how many did you roll for the long legged? Yeah, that makes sense, right? So like, for example, you've got a longer piece of paper, meaning it's going to cover more difference or more distance. So if you had to roll it 4 times, that makes sense. Also, remember that these are about 20 centimeters long. So technically 20 times 4 is 80, right? So you got it. That is correct. So that's what you're going to do for this part. Does anyone have any questions? So go ahead and roll your guys how many individuals that are born. I did do it with both, but for each one, how many individuals we had. So for example, I rolled that I had 4 offspring that had short legs and 2 offspring that had long legs. So I did 4 turns with the short legged and 2 turns with the long legged. But you, Ava, you had 4 with the long legs. So you're going to do 4 turns with the long legs, which should mean you have 2 with the short legs. So you're only going to do 2 turns with the long leg, with the short legs, excuse me. And Elias, what do you mean 100? For your long legs, how many long legs did you have? Yes, Logan, but before you repeat it, so before you repeat it, you want to make sure that you're looking carefully because the next generation, right? So we just did this and we just found the distance, right? So now we're going to find natural selection in the F2 generation. So it says that before the next generation of lizards is born, significant habitat loss for the lizard population has occurred. The lizards are now forced to travel much longer distances to find food. Individuals with short legs cannot travel as far and thus have a smaller area of habitat in which to live, eat, and reproduce than individuals with long legs. So for the F2 generation, you're going to roll the die 6 times. However, this time, only 1 or 2 is going to be short legs and 3 to 6 is going to be long legs. So if you roll a 1 or 2, that is short legs. And if you roll anything between a 3 and a 6, that is now going to be considered long legs. Okay, so then you're going to do the same thing that you did in the F1 generation. You're going to count how many individuals are with short legs and how many are with long legs. You're going to roll and turn them and find the distance and put that into the table for the F2 generation. Okay, so again, for F2 generation, only 1, okay, so only 1 and 2 are considered short legs. And then 3 through 6 are considered long legs. Okay, so you're going to go ahead and you're going to do that again. And you're going to roll it 6 different times. Questions on that? Okay. Great, so 3 and 3, Ava. So now you're going to turn the small short guys 3 times and record the distance, and then turn the long legs 3 times and then record the distance in each one of those tables. So you're going to each do that for your guys's. You got 6 for all long legs, Denny. That works. I mean, it happens. So then, Denny, you're going to turn your thing 6 times and find out the distance. And Elias, if you got 5 long and 1 short, you're going to do the same thing. You're going to turn the long legs 5 times and then measure the distance. And then you're going to turn the 1 short 1 time and measure the distance that it goes. Good. And then you're going to record it in that table. Good. Interesting. We're all kind of, we're getting different numbers, but we're still kind of getting the same trend. I feel like that's really interesting. That's great, actually. And so once you do that for this generation, you are then going to go ahead and do this for the F3 generation. But this time, the F3 generation, only 1 dot represents the birth of a lizard with short legs. And if the die lands on anything between 2 to 6, then a lizard with long legs is born. Okay, so you're going to do that, and that's going to be the last generation. And then you're going to want to think and answer these conclusion questions. And that's going to be part of your lab that is also found, and then going to be part of the discussion questions, the discussion post that you're going to be doing. And that's the lab, right? So I know it was a little tricky, but once we took a closer look and broke everything down, it made a little bit more sense. So I am here. You guys absolutely do not need to, if you guys are, wow, look at you. You and Elias both got 5 long and 1 short. Wow, Denny, but so funny to see what we all roll. But yes, so just know that I am here. We still have about 15 minutes left of class. That is the bulk of our lesson though, right? So like our lesson is going to be doing this for F2 and F3, making sure you're answering those conclusions and trying to draw some similarities to what you've learned in this lab, to what you've learned in your lessons about natural selection. So I'll hang around if you guys have any more questions, but I just wanted to give you an opportunity to get going and get started.